Ever wondered how a Coriolis mass flow meter works? It's a question that might have crossed your mind if you've ever been involved in industries like oil and gas, food and beverage, or pharmaceuticals. The Coriolis mass flow meter, named after the French scientist Gaspard Gustave de Coriolis, is an ingenious device that measures the mass flow rate of a fluid passing through it. It's a remarkable piece of technology, and today you're going to understand how it functions. Imagine a garden hose. When water runs through it and you shake the hose up and down, you can feel a force pushing back against your hands. This is the Coriolis effect at a basic level. And it's this principle that the flow meter uses to measure mass flow. In a Coriolis mass flow meter, the hose is replaced with a sensor tube, usually bent into a U shape. This tube is made to vibrate at a certain frequency, much like a tuning fork. When fluid passes through this vibrating tube, it's subject to the Coriolis effect. The fluid's momentum wants to carry it straight along the tube, but the vibration forces it to move in a circular path. This creates a twisting force on the tube, causing it to twist or rotate. The degree of this twist is directly proportional to the mass flow rate of the fluid. In other words, the more fluid there is flowing through the tube, the more it twists. But how does the flow meter measure this twist? Well, it uses a pair of sensors placed at the inlet and outlet of the tube. These sensors detect the time delay between the vibrations at the 2 points. This time delay, or phase shift, depends on the mass flow rate of the fluid. The greater the flow rate, the larger the phase shift. An electronic transmitter processes this phase shift and converts it into a readable flow rate. And there you have it. That's the basic principle behind a Coriolis mass flow meter. To recap, a Coriolis mass flow meter works by vibrating a sensor tube through which fluid flows. The momentum of the fluid creates a twisting force on the tube with the degree of twist proportional to the mass flow rate. This twist is detected by sensors, which measure the time delay or phase shift between the vibrations at the inlet and outlet of the tube. This phase shift is then converted into a readable flow rate by an electronic transmitter. The Coriolis mass flow meter is a fascinating piece of technology, providing accurate and reliable measurements of mass flow rate in a variety of industries. It's a perfect example of how a simple scientific principle can be used for a practical, real-world application. So the next time you come across one of these devices, you'll know exactly how it works.